Okay, go ahead and make sure your starters are put away and that you get a new piece of paper. We're going to put our name on it and title this water. Water is going to be our practice. It's going to be the element we're going to use for practice for this unit. For phase changes, let's actually put that water and phase changes. So we've been working on phase changes and we're still going to. So water and phase changes. Now the first thing we need to do is we need to model water. So let's go ahead and pull that up. So what I want you to do is go ahead and draw out a model like I have here. So we have the oxygen. This is the red part, the big molecule, with two hydrogens, which are the white molecules. Now you'll see how they have a plus and a minus sign by them to indicate their charge. This is why the hydrogens are bound to the oxygen. The hydrogen has a positive charge. Oxygen has a negative charge. That's what bonds our water molecule. So go ahead and take a minute, draw out your own water molecule, two hydrogens, one oxygen. The oxygen should be significantly larger than the hydrogen, just like on here, where it's pretty evident which one's the oxygen. Make sure you add charges. This will be important in the next step. So now let's take a look at what this molecule is doing in different states. So first let's look at solid. So on this, I'm going to, first I gotta get rid of my drawing. Okay, so on this, I can adjust the temperature for these molecules. So if I went to absolute zero, which is impossible to get to, but if we could get to absolute zero, that would mean that all of these are holding perfectly still. Now, what ice is typically doing when we watch it is there's small molecule movements. They're connected to each other, they're bound to each other, but they're still allowed a little bit of wobble room. Now as we get closer and closer to 0 degrees, you can see the energy builds up. So the 0 degrees is the last part before they break those bonds and become liquid. So what we want to do is draw what this would look like as a solid. Now I put it down to absolute 0 so that they would hold still so that we can model this. So when we're doing this, it's important to know that our positively charged hydrogens go to our negatively charged oxygens. You'll never see a hydrogen bonding with another hydrogen. If we watch right here, positive to a negative. So as you draw your structures, and you can draw these bonds where they're attaching to each other, you may want to do 3 or 4 of these water molecules, but make sure you're pointing the hydrogen, which is positively charged, at the negatively charged oxygen. Otherwise, it doesn't make much sense. So go ahead and draw 3 or 4 water molecules forming into solids. Then we'll take a look at liquid. Okay. And if at any time you can ask the substitute to pause this video so you guys can get your models done. But remember to be attentive and be doing your due diligence to get your work done. They will not keep it paused forever. You may have to come in for an intervention. Let's take a look at liquid. So in liquid, let me get rid of my writing. Maybe. Okay. In the liquid, we can see that they make weak bonds and it changes from atom to atom, well, molecule to molecule. Just as they get close to each other, they make these weak bonds. So when we're trying to do this modeling, you may show them being more loosely connected, able to move, but I understand you won't be able to show the movement. You may want to just draw them far apart with maybe one or two close to each other, showing this weak bonding that occurs when they get close enough to each other. So go ahead and take a minute to model 3 or 4 atoms as liquid, well, molecules as liquid, with 1 or 2 showing this weak bonding that you're seeing appear every now and again, that little lines. Remember, it's going to be positive hydrogens to negative oxygens. For your next activity, we're going to watch this video, but before we watch this video for this next activity, I want you to get on your piece of paper underneath your model, so you should have your name, water changes, water and phase changes, then your liquid model and solid model. Underneath those models, let's go ahead and draw a timeline. And at time 1 is going to be the start of the video. So we're going to call this time 1. About the middle of the video, we're going to call that time 2. The end of the video, time 3. What I want you to do at each of these different times is draw me what the model of the molecule is, what they're doing at that time. What do they look like? Okay, so let's go ahead and watch this video. So this is your time 1. What do those molecules look like? This is time lapsed. It does not normally go this fast. Water absorbs a lot of heat. And I want to call right here, time 2. So this is your time 2. What do they look like now? And this is your time 3. What do they look like now? what's going on here. So remember at the very first, your time 1, your time 2, your time 3. What do those molecules look like at each of those planes? Let's go ahead and pause it here, finish your models, and then come back. Okay, next. So what we need to do now, if you need more paper, go ahead and grab another piece of paper, flip it to the back. We're going to learn how to graph what we just saw. So what we just saw was the ice turning to liquid and then from liquid to gas. So in order to graph that, we're going to need axes. Our Y and our X. Our x-axis, let's call this time. And our Y we're going to call temp, temperature. Now, at 0 degrees Celsius is when water melts. So anything below 0 degrees, it'll stay solid and increase in temperature. Once it hits the 0 mark, something strange happens. It won't change temperature. Won't change temperature until all of it has melted. So it's going to, time is going to keep going, so this has to keep going. But all that energy is being used to make it turn into water. Now, once all of it, this will be our time 2 on that video, once all of it's turned to water, then it can go up in temperature again. Now, some of you may know what the boiling temperature of water is in Celsius. But for those who don't, it's 100 degrees Celsius. Once you hit 100 degrees Celsius, another weird thing happens. It won't go up in temperature. Boiling water will never get hotter than 100 degrees. So while it's boiling, until all turns to gas, this is where we are in that video. This is our time 3. Once it's all turned to gas, if we had a container that could hold that pressure, then the gas can go up in temperature, but that's a lot of pressure. So let's go ahead and label these different areas of the graph. So right here, solid. This one, the solid line, is solid and liquid. This one right here is just liquid. This one is liquid and gas. And this one would just be gas. Now we didn't see this in the video. Remember, this would be our time 3. This is our time 2. And this would have been our time 1. So we never saw it below 0 degrees Celsius. It was in a pan at room temperature, which means that the water, the ice, was already at 0 degrees Celsius and starting to melt. So time 1, time 2, time 3, this is what we saw in the video. So this is what happens with any element as you increase the temperature when it hits these phase changes. Phase change can't occur until it has completely changed. So make sure you have this written down. Take some time to get to know it while you're doing it, making sure you understand these vertical lines are a single phase. Horizontal lines are a dual phase, meaning no temperature change until it becomes one or the other phase. Okay, the substitute has a few worksheets for you to do. So worksheet number 1, let's go ahead and start on that. There's 5 questions. When you're all done with worksheet 1, then let's work on worksheet 2. Worksheet 2 has about the same. I think it might have 6. You can go ahead and answer those. When you're all done, you can come back to this video and we'll have another assignment for you. So let's go ahead. That's 11 questions. Let's give you 2 minutes of questions. So be ready in about 20 minutes. Okay, so now you guys have done some practice. You've worked on understanding how the graphs work. Let's see if we can do them backwards. So let's say I'm cooling. We saw what happened when I was warming it up. And I was going up in temperature, so kind of looked like something like that, right? Well, now we want to see what would it look like if we went backwards. So let's use water again. We're going to start off putting in our temperatures that are important, 100 degrees and 0 degrees, right? Now, if we're coming down, let's say we started with a gas. That's all got to condense. Then come down as a liquid till it freezes, and then it can go down in temperature again. So this is about what our graph would look like with straighter lines. Okay, so here we have gas and liquid, just liquid, and solid, and then just solid. So what I want you guys to do is I want you to draw me a graph for an element that has a boiling temperature at 253 degrees Celsius and a freezing temp at 36 degrees Celsius. What would that graph look like as it is decreasing in temperature? From, let's say, 300 degrees. Go ahead and draw me what that graph would look like. From this graph, I want you to tell me what is its condensation point. What temperature will it turn from a gas to a liquid? Then tell me what's its boiling point. When does it turn from a liquid to a gas? What is its freezing point? And its melting point. So draw this graph and give me these four things. Once you're done with that, tell me how they're related. Are any of these related? How? Okay, it's very important that we understand where the phases exist, where both phases exist. And you'll see that on the horizontal bars, both phases exist. The vertical bars, only one phase can exist. It's important to understand that, and that these are what we call like either the melting, condensing, boiling point. So this would be the melting and the freezing point, and this would be the condensation and boiling point. They're the same thing, it's all dependent on what direction you're going. When you're going down in temperature, it's condensating and it's freezing. Going up, if we change the time to go this way, then this is the melting point and the boiling point. So it's all about direction, whether or not we're talking about the direction of temperature, and whether or not we're talking about a boiling point or a condensation point, or a freezing point or a melting point. So make sure you understand that these are related to each other. It's all about direction, all about direction. Make sure you put that in your notes if you haven't already, all about this graph. Make sure you understand these things. All right, that's it for today. Make sure you put these in your binder with your names on them so that we can go over, so you can go over these and make sure you're ready for the assessment when it comes up. Thank you, everyone. Make sure you thank the substitute on your way out today, and I look forward to having a good review.